All right, boys and girls, welcome back to the drive-through. Recovering from an awesome PVL bell, and now we're back in to 9-4. Okay? We're talking about relative frequency tables now. Here, what we have here is just a frequency table. You'll remember this is the data from 9-1, now put into a frequency table, not a relative frequency table. This is just a frequency table. What does it describe, Carson? It does. It describes how many category. Yeah. How many of each category, people from different categories, texts they send per day. Okay? So, 20 of the 24 teenagers send over 100 texts per day. Therefore, 4 of the 24 teenagers send. Got it? You're all over this? Okay. Now, let's write 2 observation statements about this two-way table. So right now, this is totally review. Give me one, Carson. Adults, you can do better. His statement was adults don't text as much as teenagers. That's fine. How about adults are far less likely to send 100 texts in a day than teenagers. Is that good? Overall, love it. People are slightly less likely to send 100 texts in a day. To send more. Is that good? Okay. All right. Rachel decided to do some research. She found that only 43% of people with phones send over 100 texts per day. There you go. She was disappointed that the data did not support her case and confused because it did not seem to match what she had found in her survey. What questions do these statistics raise for you? So it seems like 22 out of 48. What is 22 out of 48? 46. All right, so in Rachel's survey, she had 22 out of 46, which was, what did I just say it was? 46%. So in Rachel's survey, she had 46% of texts. 47, 22 out of 46? Sorry, 48. I must have hit something wrong on that calculator. Thank you, Carson. So Rachel found that in her survey, 48% of the students sent 100 texts or more. But then she did more research and found that only 43%. So, just what questions do the statistics raise for you? Well, what do you think? I disagree. I don't think it's her calculations that are wrong. I think it depends who you survey, right? If you surveyed teenagers in Zimbabwe, you might get a far different result than if you surveyed teenagers in Montgomery, right? So that's one of the things. It depends who you survey. What data should Rachel look for to support her case? Survey a large group from a wide variety. Does that make sense? All right. After looking more closely at the data, Rachel found other percentages within the same data that seemed more accurate with the data she collected from her friends. How might Rachel use the data in the two-way table to find the percentages that would be useful for her case? I'll answer this just for percentages. Take the, what do they call the take the subgroup, divide over the large group, and compare the results as percents. So that's what we're going to be doing for the rest of the time. Okay? Alright, so now we're going to get into conditional frequencies inside of a relative frequency table. So this might say, what's the probability, or what's the percentage of adults that send more than 100 texts per day? Well, that would be 2 out of 24. No, 2 out of 24. So you're going to have to really keep these columns and rows sorted. Okay? So that's what this reading is all about. I encourage you to read it. There's nothing that needs to be done here. But now we're going to get on and take a deeper look at it. Okay? So remember that columns hold up buildings in Rome, right? These are columns. Columns are vertical. Rows are horizontal. It's like a very important thing to know in math right now. So, what percentage of teenagers send 100 texts in a day? Well, how many teenagers were there? And how many of them? No, there were 24 teenagers. You got to go across, okay? There were not 22. There were 22 people that sent 100 texts a day. So you really got to be careful about whether you're reading the row or whether you're reading the column. How many teenagers are there? There are 24. How many of them send 100 texts or more in a day? So now do 20 divided by 24 in your calculator. So all you do is 20 divided by 24, enter. You get 0.833. As a percentage, you're going to move that to here. So it's 83.3%. Nope, not if you want to be accurate. Because all of these things need to add up to be 100. And if you round it off, that's not going to happen. Okay? Now, so I could find this really easily without doing math. I mean, I would still need to use it. But I could just do 100 minus 83.3, right? Because you either send more than 100 texts or you don't send more than 100 texts. So I'll just do that, minus 100. That's going to give me the no. 80, clear. 83, clear. 100 minus 83.333333333, enter. You're going to get, I keep doing this, 100 minus 83.33333, enter. And you're going to get 16.6 repeating here. Okay, so far so good. Notice the rest of it has been filled in. Okay, so of all the teenagers in the survey, 83.3%. Write another statement based on the relative frequency of row. Okay, well, of all the teenagers in the survey, this is called the complement. How many? Okay? Moving on. All right. Teenagers. Is it a row or a column? It's a row. Number of texts in a day, row or column? Column, excellent. Below is see, this is now a relative frequency table. Now it's a relative frequency of columns. Notice, where is the 100%? Here, on the rows. On the rows. See how this is a 100? These are 50s. So this is a relative frequency of columns. Okay? So now, write two conditional statements using the relative frequency of a column. Well, let's go to the one we haven't said yet. So give me a statement about the relative frequency of a column for. Give me one for adults.
The number of teenagers and adults
I like it. It's very well said. I wasn't even thinking that, but I think that's a really important stat. If you look over to this column, I was kind of focusing on these two columns. If you look over at the final column, you will notice that each of those is 50%, and that's important. Now our audience knows that this is a fair survey, at least in the sense that we interviewed the same amount of teens as adults. Now give me a statement, Carson, about an adult from a row. Okay? Love it. Love it. Moving on. Create two conditional distribution statements for the relative frequency of the whole table. I'm going to pause. Okay, so we're going to put this over here because I don't think we have enough room to do two, okay? All right, this is a little bit confusing. What we need, Carson, is basically interpret information from the purple zones. So, like, basically, you kind of already did one of these. That there is an equivalent, okay? But that's okay. It still was from a column. So give me something from the bottom purple column that you could interpret as a conditional statement. Relative frequency conditional distribution. I think so. There was a total, because it's involving a total, of 48 people surveyed. Give me another one. From the purple. So give me a statement about the total number of people that send less than 100 texts in a day.
There were a total of 54% people
that sent less than 100 texts per day. Okay, good. So those are whole values. And now what information is highlighted when data is interpreted from the relative? What information is highlighted? I think that's information about the total population. Whereas when we look at the relative subgroups, those are the subgroups. Those are like just the males, just the females, or just the teenagers, just the adults, or just the over 100, just the under 100. Is that it?
Yeah, I think so.
Yeah? What do you got to say about that? Boom!